So now let's try a problem. So Old MacDonald had a total of 23 chickens and pigs on his farm. So total 23 chickens and pigs. Altogether they had 70 feet. How many were chickens and how many were pigs? Now, some of you are automatically getting out a piece of paper and finding all the answers already. But before you start the problem, I want you to use the 4-step problem solving method and the template to really make sure you understand it. So try the entire problem on the template that I just provided with you before you go on. Then check your template with the rest of the slides. So pause your video, work out this whole problem, and then come back and unpause your video and see how you did. Great, let's take a look. I did the template and I cut it out into little pieces so you could see each step. So understanding the problem. First we write down what we know. You notice I wrote total 23 chickens and pigs and 70 feet total. Then we write down what we're trying to find. In this case, we're trying to find out how many chickens and how many pigs on Old MacDonald's farm. Notice I'm very specific with that. The conjecture or prediction, usually I give something that's too low and too high, so I can kind of narrow it down. So he said he has chickens and pigs, so I figured too low is 1 chicken and the rest pigs. And then, because that doesn't give you enough legs, or that gives you too many legs, wait, 1 chicken, 20, yeah, it would give us too many legs. So, and then less than 20 pigs. So if we have less than 20 pigs, I knew that 20 pigs, 20 times 4, because pigs have 4 legs, would be 80 feet. So I knew that was too big. So I had to make some adjustments there. So those were that was only step 1. Notice I didn't do any math. I'm just thinking about things. Maybe doing a little estimating, but that's it. Step 2, devising a plan. So now we're going to decide what's our strategy for the problem. So I might draw a picture, I might create an equation or a table. So you might have different strategies. I wasn't sure what I was going to do, so I circled all 3 of those options. Now on step 3, I'm going to do whatever I said in step 2. Notice that I showed mine in 2 different ways. On the left-hand side, I showed a table. So how many chickens, how many pigs, and then I showed how many feet they would have all together. And then I wrote little notes to myself about how I could narrow things down. On the right-hand side, I used an algebraic strategy, which most elementary students would not have, but you might have that as a teacher. If you solved it algebraically, I want you to try to solve it in a different way, not algebraically. I've had people draw 23 circles because it said they had 23 animals and put 4 legs on all of them and then take off legs till they got to the right number. I've had that work in reverse as well. So it doesn't matter what your strategy is as long as we can follow it. So now notice I have my answer on this one. Old MacDonald has 11 chickens and 12 pigs on his farm. But I'm not done. Even though I have the answer, I'm not finished. So step 4, looking back. This is the step that most students skip. So they already have the answer, so why is there another step? This step is to verify your mathematics. You maybe want to do your problem a different way, work backwards, compare your result with your conjecture, or go back to the original problem to make sure you meet all the criteria. In my looking back, I went back to the original problem and calculated to see if I met the requirements. Notice that I stated I know my answer is reasonable in words and showed some mathematical calculations. Both of those are important for that looking back or verification step. So here's my whole template all together. I know it looks like a lot of work, and it is, but it's a great way for students to break down a problem that they may feel is really hard and have a starting place to explain their mathematics. So even if you don't know how to get the answer, you at least know how to start.